This is still chapter 9. Okay, this is section 2, I believe. Okay, so as I mentioned before, okay, chapter 9 is all about chapter 8. It's just now that we have 2 populations to deal with instead of 1. Okay. All right, so let's look at this problem here, and we're gonna go through the process, the entire procedure to test this thing. Okay, so here it says 8 male and 8 females college students who have credit cards, and these numbers shows their credit card debt. Okay, so for the males, the mean credit, for the males, the mean credit card debt is 1,138 and a standard deviation of $493. For the females, the mean credit card debt is 1,488. Yes, it is 1,488 with a standard deviation of 642. Okay, so this is represent the college debt for college students. Okay, so a researcher claims that there is a difference in the mean credit card debt all by male college students and by females. Use alpha 0.05 level of significance. Okay, so here I'm going and collect some information here already. So kind of went through this process. Okay, but let's review this together. Okay, so based on what they gave us here, we have college card. We have we have credit card debts by males and female college students. Okay, so based on the information they gave us, we know now that for the male college students, I'm going to make it a X bar 1, okay, for the male college students, and then X bar 2 for the female college students. Once again, if you want, you can make you can switch and say X bar 1 represent the female college students. Okay, so it's up to you. Here I chose male college student to be the first population or first sample, so the 1. Okay, so X bar is 1138. We're told, right, that the mean credit card debt is 1138. And also told that 8 female and 8 male. So N1 is 8 and N2 is also 8. So N1 represent those 8 male, and then N2 represent those female students. All right. S1 will be representing the male college students, standard deviation, which is 493. S2 represent the standard deviation of the females, which is 642. Now, look at the claim, okay? The claim says there is a difference between the average credit card debt by all by males and females. So the claim says there is a difference difference means that they're not the same, right? Difference means not the same. So that's why the average college card the average credit card debt by males is not the same as by females. Okay, so that is your claim. Okay, so we use the mu1 not equal mu2. This is saying there's no difference in the average debt. Okay. If the claim is not true, which is I call that alternative claim, then mu1 must be equal mu2. Remember, mu1 represent the mean credit card debt by the male college students. Mu2 represent the average credit card debt by female college students. Okay. Now this information here, we're talking about those 8 females and 8 females and 8 males college students. So this is a sample. Okay. When I make a claim, I says all male college students. That's why you use the word. That's why you use the letter mu. Okay. Okay. So based on this, we can say that which of these two will belong to H1 and H0. Okay. So if you remember, H1 has the inequality, so this one's gonna go to H1. H0 is always had the equality, so this one's gonna go to H0. And so here we have, right? Okay. So here we have this step 1, 2, 3 here. So H0 mu1 equal mu2. H1 mu1 is not equal mu2. Okay. That step's easy. Step 2, alpha, I just put 0.05, right? Because this is we're told that use alpha 0.05 level of significance. So alpha is 0.05. Now step 3, the test statistics here. Okay. We're talking about the mean, okay, the average, and we also talk about independent samples because male females are independent. Okay, each group is independent from another group. Actually, one group is different than the other group. Okay, so we have 2 independent samples. Okay, independent samples. That's what we have. And based on this information here, we're not told anything about the populations. They just straight a claim. So we're not assuming that we know the standard deviation for the populations of those males and college female students. Okay. And we don't pretend that we assume, we don't pretend that we know the standard deviation to be the same. So you can see that sigma 1 and sigma 2 are unknown. Okay. Because we don't make any assumption, then we now assume that sigma 1 is equal to sigma 2. Okay. So here it is. This is the test statistics for 2 independent populations. We use the t-test. Okay. Okay, so this is always 0. Don't forget, right? You can always ignore the x1 or the x. So this could be the mu1, minus mu2. This is always 0, okay? Right, so we have this mu1 minus mu2, and I told you last time, oh, I told you that, actually, I told you when we look at the formula sheets, that mu1 minus mu2 is always equal 0. Same with P1 minus P2, always equals 0. Okay, so this is the formula for the test statistics for 2 independent samples. And we don't know the standard deviation for the populations, and we don't pretend to know that they are the same. I mean, the standard deviations of those 2 populations, we don't assume that to be the same, and that's why we have here. So this is the formula. This is the formula we're going to use. Okay, so T1 bar, actually, sorry, X1 bar minus X2 bar minus, right? You're supposed to have mu1 minus mu2, but because this is going to 0, that's why I just pretend. I just know that this is going to go 0, so I put 0 there. Divided by the square root of S1 squared divided by N1 plus S2 squared divided by N2. When we get the information here, we already know N1, N2, S1, S2, X bar 1 and X bar 2, so we just plug it in, okay? So here we plug it in. 1138 minus 1488 minus 0 divided by the square root of S1 squared, so 493 squared, divided by N1, which is just 8, okay. S2 squared, again, that is 642 squared, because S2 is 642 right here, okay. N2 is still 8. So when you put this in your, when you put this into your calculator, you should get about negative 1.223. Okay. Now that's done. The next step is to either get the p-value or get a critical value. So we're going to use the critical value this time. Okay. So here we go. We're going to use t sub 0 for the critical value, okay, so that it is separate from those, the t, this t for the test statistics. Critical value based on alpha. So here, we can look at degree of freedom, and we have 2 populations. So one for female and one for the males. So N1 is 8, N2 is also 8. So N1 is the same as, dF1, degree of freedom of the first population, is the same as the second population, dF2. This case is males and females college students. They both have 8 as their sample size. Yes, 8, 8. So here, 8, 8. So the degree of freedom is just 8 minus 1, so it is in fact 7. Now, if you look at formula sheets, it would say degree of freedom smaller of these two. Okay, smaller of the F1 and the F2. Well, in this case, since they're both the same number, then we can use just the 7. Okay. Now we have a two-tail test. We have two-tail because what? H1 says not equal, then either gonna be gonna be less than or greater than. So that's why you have 2. Okay. If we have two tails, then we have a areas in two tails, which is the 0.05, which is the alpha. Okay. So look up the table. Degree of freedom is 8, and area in two tail is 0.5. So let's look up this table. So let me share this table. We all look at the alpha is 0.05, which is area in two tail, and degree of freedom is 7. So here, this is the table. Area in two tail is 0.05, so we're here, 0.05, area in two tail. Degree of freedom is 7, so right here. So when you go left from 7 to the, actually you start from 7, right? You go to the right, okay? You start with 0.05 of area in two tail, you go down. So you can see that your critical value T is 2.365, okay? Now the fact that we have a two-tailed test, then we're gonna have a negative and a positive 2.365. And so here we go again here. Okay, so critical value T is positive negative 2.365. Okay. Here I draw this graph. Okay, so left tail, right tail. Okay. Critical value T 2.365 on the right, negative 2.365 on the left. Our test statistic is from step 3, we have negative 1.332. So right here, right, you can see right here that this is the test, this is test statistics, which is negative 1.223. And if you remember that this is T, right, in the middle here is 0. Okay. So you can see that this test is not inside the critical region. Okay, so we're gonna fail to reject A0 because we see the test was not in the critical region, CR. So step 5, reject A0, no. will not reject. We fail to reject. Why? Because the test, our test show that it's not in the critical region, and so we're not rejecting age 0. Right, next step here, conclusion. So here you can see that the fact that we fail to reject, so we have no evidence, okay? And we tend to support the H1. So with H1, H1 is saying not the same. Say that it is no difference. So this one's saying that, I'm sorry, mu1 not equal mu2 tells me that there's a difference. So if that's the case, then mu1 equal mu2 means that there is no difference, okay? So there's not such evidence to support the claim that there is a difference between the average college debt owed by males and female college students.